Thank you, Antonio. And so now we'll go to our next and concluding session, which is about global strategies, global approaches to this connectivity challenge, particularly with respect to, the lower income and rural areas. And our moderator for the session is Cecilia Kang, who is, I know, well known to most of you. She's the national technology correspondent for the New York Times. So Cecilia, maybe you can they'll come up one at a time, but you can just introduce them.
Should I sit down at each? Should I do them all at once?
Yeah, sure.
Yeah, great. Thank you, Michael. For this next presentation and panel discussion, each of our participants will have a presentation. We are joined by Marian Croak, who is the Vice President of Access Strategy and Emerging Markets at Google, Greg Weiler, who's the founder and Executive Chairman at OneWeb, Bob Pepper, the Head of Global Connectivity and Policy and Planning at Facebook, right there, and Paul Garnett, the Director of Affordable Access Initiatives at Microsoft. So they will each come one by one and give a presentation, and then we'll chat afterward.
I'd like to thank Michael for inviting me to the forum, and I'm very, very excited to be here to tell you about some of the key initiatives that Google has underway in the emerging markets. And before I get started, let's see. Somehow, okay. Maybe you can help me find it.
Ask them if they can put it on.
Okay. I mean, I can talk about the slides, so that's fine, but I'd like to have them.
Well, hold on a second, because that's into
Okay.
legs.
Greg, you look great. Yeah, I could probably talk through yours. So before I get started, though, I wanted to share with you our perspectives on the emerging markets. And I have a chart, once we can get it projected, that shows that there's been an amazing amount, almost exponential growth in the amount of connectivity that is within these markets, and that's measured by mobile subscribers. So I think it's factual. During that same period of time where you see this exponential growth, you see a flattening within the domestic markets. So there's 7 billion people now, which is 95% of the world's population, that lives within range of a cellular network. And 2/3 of the people on the planet live within range of a broadband network, which means that they support or they have the ability to have access to speeds of 3G and above. And as we visit the emerging markets, what we also see is this rapid deployment of LTE networks. That's within India, Cambodia, Vietnam, in South America, Latin America, and even within small parts of Africa. So we see a lot of progress, and if you look at the people that actually live in these countries, you see very vibrant cultures. First of all, most of them are very young. 45% of them are below the age of 25, and they're becoming increasingly urbanized. In India, for example, 90% of the population growth is predicted to be within cities, and that's within the next few years. When you look at city dwellers compared to rural communities, 3 times as many people that live in the cities use smartphones as do in rural areas. So smartphone penetration in these markets is predicted to grow by 60% in the next 2 years. That's a very important data point, Because as you saw what happened here domestically, when people start using smartphones, it drives the demand and the usage of broadband networks. Are my slides there? Oh, good. Thank you. Perfect. Yes, exactly. And then finally, people in these markets, although you see a vast amount of poverty, so I don't want to paint this rosy picture, there is an increasing amount of disposable income. So 80% of the people that are mobile subscribers use prepaid plans, and they're very savvy, much more so than we are, about how to use mobile networks. They have multiple SIMs, so they can move very easily among operators as a function of whichever voice and data plans are most economically viable at any moment in time. I fumble with trying to do that, and they can do it within a snap. So, you know, it's a very, very large set of changes that have happened within the last 2 years, and we see these changes happening even more aggressively in the next couple of years. Despite this, okay, and as we heard a lot about this morning, we see, oops, we're going backwards. We see that there is still a huge disparity between the coverage that is available to people and the number of people that are actually using the internet. Over half of the world's population have never used the internet. And that's particularly true in the countries that are in red and yellow on this chart. So 75% of the people in Africa are offline. And 2/3 of the people in Asia and in the Pacific do not have access to the internet and are not using it. So it's still a huge problem that we're trying to solve, and Google is, oops, we're going backwards again. Google is really working hard to address these problems. And even though within each of these regions there are very unique reasons why there's this huge gap in coverage versus usage, there's a lot of commonality across the emerging markets that produce these factors. People have low-spec phones, so that means they have very limited storage and memory. Power sources tend to be unstable, so using phones can be difficult because of the battery life. Networks tend to be very congested, unreliable, and bandwidth constrained. And data plans, as I said, can be very expensive. And then finally, if you look at the content that is available on the internet, it can be highly irrelevant to local populations. So just looking at, say, Wikipedia as an example, 1/50 of the content that's available to English speakers on Wikipedia is available in Hindi, despite the fact that Hindi is the 4th most spoken language in the world. So within Google, let me see if I get this right. No. So within Google, as I said, we're doing a tremendous amount of work to address these problems. You'll see dramatic improvements in the amount of localization, for example, that we're supporting, both in respect to language as well as content. So across our products, including search, YouTube, and especially Android, Maps, Translate, you'll see a lot of new language support. And these charts are probably a bit out of date in that we are supporting new languages almost on a weekly basis. So these are just from a few weeks ago, but you'll see more languages rolling out each and every week. We are also working very hard to adapt our products to accommodate the limitations of the networks that we're encountering in the emerging markets. So again, you'll see offline versions of the most popular applications within these markets. including Play and YouTube and Maps, as well as search. Translate is also being developed for an offline version, so when people don't have network reliability or connectivity, you can still get the information that you need from the internet through these offline variations of these applications. And then finally, in a related effort, we're trying to be very sensitive to the concerns that people have about using their data and the expensive data plans within these markets, and also to compensate for the slow networks that exist within these markets. We're doing a tremendous amount of work to optimize the compression technologies that we're using in our services so that they consume a lot less bandwidth than they normally have. And you'll see across the array of products and applications that we support what we call light versions of these applications. In parallel with the work that we're doing on adapting to the existing network conditions within these markets, we believe that it's very important to actually improve the networks. So we are focused on creating more affordable and abundant access in terms of underlying network infrastructure across the emerging markets. And we have been doing this for quite a few years, and we have many models that I'm going to talk about in respect to both business as well as technology in serving these markets. But the one thing that we have found and that we are going to be increasingly emphasize is the need to work in partnerships in order to rapidly expand the work that we're doing and to have a broader reach and to accelerate the pace at which we're going. So, you know, I welcome any partnership opportunities within this room, and we do have many partners sitting with us today. And we are open to inviting more of you to join us in this journey. We also believe very strongly that we have to have a very strong advocacy with governments in respect to policy and regulatory fronts, and we're doing that also in a much more aggressive way than we have in the past. So let me just give you a few examples of the work that we're doing and the models that we're using to create these new networks. Across both domestic as well as global regions, we're providing Wi-Fi. And we're doing so in New York, we're doing so in retail, enterprises like Starbucks. We're working in India as well as Uganda. But I'm going to focus on India in particular to just give you a flavor of the types of work that we're doing. We've started working with the Indian Railways and Railtel, as well as the government of India, to build the world-class Wi-Fi networks across train stations within India. And we're doing this in a very successful way, and we're working towards creating financial sustainability in the work that we're doing. We started this in less than a year ago, and we've already made significant progress in doing so. As I said, we're working very closely in collaboration with the Indian railway system. And as they were building their railways, you know, if you know much about India, it's a huge country, and these railways traverse the entire country. There are over 4,000 stations within India. And when the railways were building their train tracks, they had the foresight to lay fiber along the tracks. And the fiber is highly resilient. It's a very well-designed fiber network. So we're using that fiber as backhaul, and Google is deploying and managing and operating Wi-Fi networks within these stations so that users who are waiting on these platforms can get very high capacity bandwidth that's equivalent to being able to watch high-definition videos, download information about their upcoming destinations. And what we're finding is that people just hang out at these stations in order to use the Wi-Fi that's available. If you look at this chart, we have a commitment to build out over 400 stations, and we're really doing it at a very accelerated pace. We've already built 112 Wi-Fi networks or hotspots in these stations. And when I say building these networks, I mean within each station, according to the density of the people that use the actual station. And in India, most of the population travels through these stations. It can mean that there are dozens and dozens of APs within one station. So that's what I mean by hotspots. So we've built out over 112 stations. We have a little over or less than 300 to go. 6 million active users on a monthly basis use these Wi-Fi networks. And the thing that I think is most just very, very inspiring to us is that at least 15,000 new users to the internet are using, per day, are using this network. And that includes a lot of high school students that come to the station to complete their homework. And that's very inspiring, makes you want to get up in the morning and go to work. So we're continuing to build that out. And as I said, we're doing it in partnership with the governments and with the actual operators, the ISPs that are within India today. Last December in India, we announced that we are going to take this initiative, build out to other venues within India, and then also productize it and build it within other countries as well. Now, in order to use a service like this, you need very good backhaul. And fortunately, within India, we had that. In other countries, we may not, and we'll do different variations. Turning to that, if you look at Africa, we found that there was a lack of very good fiber network within the metropolitan areas of some of the countries. And it's not because it didn't exist, it was because there was a stranglehold on it. So what we built were wholesale metro fiber hubs that were accessible to any operator, any ISP, any MNO that wanted to use it. And those MNOs and ISPs then use that metro fiber backbone or metro fiber hub to offer retail services to their clients. And they do so in an affordable way. And they can avoid the CapEx and the operational cost of building their own networks and having to operate their own networks. And we have found this to be a very, to put it in diplomatic terms, a very important way to get around some of the monopolistic practices that we have found in these countries. We are working through a separate entity under the name of C Squared to operate these networks in Africa, and we'll be increasingly working with partners, many other partners, to build out across the continent and to expand our reach within Africa to build these metro fiber hubs. So you'll see more information about this in the coming months as we expand these opportunities. One country that I think is extremely important that we're going into next is Liberia, because they are in desperate need of a communications network. Finally, what I'll talk about is Project Loon. I think many of you have heard about it. It is an extremely exciting project. It's being built in X, which is a sister company of Google and serves as an innovation lab for all of Alphabet. X is really a network of balloons that travel at about 20 kilometers within the stratosphere, which is a little above the weather, and they're designed to provide connectivity to very remote rural areas across the globe. They work very closely. When I say they, I mean Project Loon is working very closely with local telcos in these communities to test out whether or not these high altitude balloons can provide the connectivity to very hard to reach terrestrial areas across the planet. And they've had tremendous success in doing so. Since they first started testing Loon, I believe it was in 2013 in New Zealand, they've flown over 16 million miles with these balloons. And they have discovered a way to connect balloons that are over 100 kilometers apart through lasers so that they have communication between the balloons. And most importantly, they have really been successful in being able to beam down LTE level connectivity to handsets that are on the ground. So people in these very, very hard to reach, less densely populated areas on the globe now have connectivity through these balloons. Now, I don't kid you, Loon is a moonshot. It's a technology experiment, but it is succeeding. And so they're working very aggressively across the globe and within other countries. Right now they're focused in Latin America and doing a lot of experiments there and a lot of trials there, but they are having tremendous success. So let's wait in about 5 years and maybe we'll solve one of the biggest problems in the world, which is how to reach these very low density rural areas. So in closing, I just would like to say that it's very clear from the work that we've been doing that there's no magical solution, one solution, either in respect to technology or business, that you can use to solve all of the Earth's problems in terms of connectivity. So Google is applying a lot of different models, a lot of different technology solutions across the world to reach these different geographical terrains as well as population densities. And we are doing so in a way that really requires us to partner with all of you. We have no competitors in this space. It's a huge problem, as you know, and so we welcome your partnership in pursuing how to resolve this issue finally. And we hope to do so by 2020. Thank you.
Thank you. That was a great presentation and fun to watch. I think you, I'm not sure how to get back to my presentation. Just forward? Okay. One way or the other. Thank you. Here we go. Oh, hey, it all worked. But I think what Marianne ended with is where I want to pick up and start, which is our mission is enable affordable access for everyone. But it's not really my mission or our mission at OneWeb. It's our mission. Everybody's mission. Everybody in this room is part of the same mission. And often I get the question about competition. And they're like, well, you know, LTE and telecom operators. And I talk to governments all over the world. And they're like, well, we have this plan to run fiber here and to connect that village and run fiber there. Even in very developed countries that have, typically even a developed country, except for like Singapore, has 10 to 20% of their population without good quality access. In fact, in the US, over 50% of the population doesn't have access to broadband. So we've got a really big, serious problem about getting broadband everywhere. And I always hear that. I'm like, just go invest in fiber, go run everywhere. OneWeb is just the internet catch-all. We will just take the last couple of percent that you haven't gotten done. If you haven't finished it, we'll figure out how to get the last people on. And one thing that I've realized from doing this, a little bit of my background is went to Africa and started running fiber and connecting schools. I did that after I sold my first company in my 20s. This is a younger version of me. And ran fiber, had actually 3,200 people at one time trenching. And it's really hard. It's like really hard because you got this little 0.62 millimeter strand and you're trying to get it to every house within miles or kilometers around you. It doesn't happen very easily. So as hard as you try to get fiber everywhere, it's basically impossible. No, I mean, it's almost impossible. Like if we devoted all of Earth's resources to getting fiber to every school of the world, we could probably do it, but we wouldn't do anything else for the next 10 years, and all of our money would be sunk in it. So it's theoretically possible. It is a big journey to run fiber into rural places. And frankly, what I've learned from it, from running fiber in some very, very difficult territories, this is just in Mount Karisimbi and Lake Kivu, which is a hot spot between Rwanda and the DRC and Uganda, right in that sort of area. I learned that it's just, I mean, it's hard, and it's probably not the most economic thing to do. So I also, just a little bit about history, I also built the first 3G network in Africa, and so I started having towers with generators, but then you have to run gas to all of them, and it becomes hard to make sure the gas shows up, it's in there. So we went to solar-powered systems. This is in early 2000s. And I used really local teams, so they connected their own homes. And it was a labor of love and a lot of fun. But what happened, I realized, is that I had built out this network that had really high speed internally, but couldn't get to the global internet because the nearest fiber drop was 5,000 kilometers away. So I tried to run fiber down the East Coast, and that really didn't, of Africa, that didn't really work out too well. Too many political countries and ministers and it's just too much to run through many, many countries. So I said, well, why don't we bring the satellites closer to the Earth? And I was too stupid to know that it was really hard. So I decided, I designed a system, I acquired the spectrum rights, and we designed a system and decided to raise $1 billion in 2008, which was great until 2009 came along. Google was one of the early investors, and that was great. And Larry really helped to spur it along, and built 12 of these called O3B networks, which O3B, when I named it, stood for the other 3 billion. And so I'd go around the world and I'd try to explain to people, hey, I need $1 billion because I need to bring internet to people who don't have any money. What? And back then $1 billion was a lot of money to raise. So, but fortunately, through a lot of really incredible investors and an enormous amount of luck, built 12 of these, and they're up and running today, and they're all around the world, and over 50% of the Pacific Islands are running on them. They're the world's fastest satellites. They do over 2 gigabit per second on a single beam at 130 millisecond latency. And that was the key to bring that latency down. So we built about 10 of these big Earth stations, or ground gateway teleports around the world to support it. But around 2012, I really started thinking, hey, this is great for telecom head ends, but we still have this huge problem. We still have over 50% of the world without access. So how are we going to get right to the home? How are we going to get right to the school? And it was really sort of, something I started to think a lot about. And I went out and I said, I think it's possible. What if we could connect every school of the world and give them at least 50 megabits per second, have a solar-powered, self-installed terminal, have it Wi-Fi and LTE so that if you show up with a Vodafone or a Digicel handset, it just works, right? So, and the high school girl who installs it gets paid a little bit of revenue for providing the infrastructure and maintaining it for the school because all the people around there are getting access. So really started to focus on LTE and Wi-Fi technologies, but also on how to design a satellite system to accomplish this. So the place where you always start if you want to build a satellite system, just building satellite systems 101, is you go to the ITU. They're the god of satellites. Everything above 100 kilometers, they are the spectrum gurus. It turned out that there was a nice chunk of spectrum available that nobody was using because it had to operate in a special way. It had to operate without interfering with the geosatellites. So we had to design a system that wouldn't interfere with the geosatellites, and which we did, which unlocked this very large chunk of spectrum, 3.5 gigahertz of globally harmonized spectrum, which we could then use to provide services around the world. Now, that spectrum was set aside specifically for the mission of connecting rural areas. When the ITU went through that in the year 2000, it was about rural connectivity. And so we were very pleased that we could manage to unlock the value of that spectrum and make it available, but also that it was right on target with the mission of the ITU. And so we've been very active with them and around the world with governments about how do we connect all their schools. One of our missions, two primary missions. Our primary mission number one is we're going to connect every school of the world by 2022. So I hope everybody in this room connects all of them, so then we're done with no work. But in case you miss one, we're going to get out there and we're going to connect every school. That's our mission and our plan. So and I'll show you how we're doing that. The second one, and many of you may know, we went out and I initially funded this myself, and then we raised a first round about $500 million, and then just recently we announced I was going to raise a second round of $500 million and a third round of $500 million every year, but this round we ended up raising $1.2 billion. So it really gave us, now we've raised over $1.7 billion, and plus our debt, we're now fully funded, or very well funded, more than fully funded, because we need less than that. But we have a plan that's very methodically thought through with our spectrum as the cornerstone to provide services on a global basis and to solve this problem. So we bumped up our plan from connecting every school in 2022 to bridging the digital divide by 2027. That means everybody in the world who wants access will be able to acquire it at a GDP-adjusted affordable rate. So it'll be cheap in some areas and not so cheap in other areas, but competitive with the local GDP environments. And that's a big, tall order. And I'll show you some of the stuff that we're doing to get there. So we have our satellites that we've designed. Our satellites are very far along. In fact, our production satellites are launching in March of next year, about 1 year away. We're launching 10 of them. And then right after that, we start a campaign where we'll be launching every 21 days. So our rockets are actually in production now. Some of them are built, the frigates and the pieces and the components. The third stages and stuff are stacking up as we speak. Well, not fast, but slowly, like one a month or one every 2 weeks or something. But the pieces are underway. But the key thing about this system is we brought it down to 1,200 kilometers. And a geosatellite's at 36,000 kilometers. So it's so far away that the latency is very high. You click and you wait. And any dynamic HTML and video conferencing that just really bogs down, doesn't work very well. So if you want to be part of a classroom experience where you're working long distance remotely off your classroom, it doesn't really work because when you ask a question, they're on to the next question. So if you want to bring these kids in so that the kid in a Mexican school can have the best math teacher in the world and participate with everybody else, you need to have low latency so they can speak live like we're speaking now. Virtual reality, latency is really important. So if you want to have, and this will happen, we will have kids who are sitting in classrooms, but they won't be in the classroom. They'll all think they're in the same classroom, but they'll be wearing the VR. And VR is coming, and it's going to be really big, but it's extremely demanding on networks. O3b, we brought the satellites down to 8,000 kilometers. So it's 130 milliseconds. Big improvement in connectivity. Very, very, from most applications, that's really good enough. The ITU standard is 150 milliseconds for audio conferencing. So it was fine for voice and other. But there are some applications where we brought it down to 30 milliseconds, which are really important. So we brought this system, OneWeb, is down at 1,200 kilometers. 30 milliseconds is about the average in the US for sort of fiber and cable modems. We wanted to be equivalent in capacity and performance to a cable modem. So here's the number one reason why you have to be that low latency. If you want to do cellular backhaul and you want to have be able to hand off between one tower to the next, and you guys might say, well, I don't know what you're talking about, the technical details, but ignoring the technical details, as you drive down the highway and you're on Tower A and you're driving by Tower B, at some point it hands you over. And you can't do that if, when you're talking to the computer in the background, it takes so long for them to tell the computer in the background, hey, ready? Hand me over. So 30 milliseconds, we meet all the LTE standards. So our backhaul on a cell tower is completely transparent to the LTE network. So you can have backhaul from OneWeb, backhaul from fiber, and then backhaul from a cable modem. And as you drive by, you'll just hand over tower, tower, tower. And so it's really easy for cellular operators to bring connectivity globally. An example is a backhaul integrated small cell. So let's take the US, developed country. Anybody been to Vermont? It's not so great, the connectivity. You drive up 95, you go to the top of a hill, there's coverage. You go to the bottom of the hill, there's no coverage. Drive to the top of the hill, there's coverage. And you go like that for miles on end. And so this, you could stick a terminal anywhere you want, and instantly it will be part of the network. And it will connect and hand over and fill in all the little dark spots around the world. And they're everywhere. They're even in DC. So the backhaul integrated small cell will allow, including if you put in lighting on it, for a lot of emerging markets to have actual coverage as well as lighting and other safety features. So that's going, this is a very exciting thing, and we'll be demonstrating some of this at Mobile World Congress. I should say one of our larger shareholders is Qualcomm. And so they're building the chipsets for our user terminals, and they've done a lot of work in making sure our small cells are integrated with LTE so that it's all going to work seamlessly. So another aspect of what we're doing is you can drop a terminal in a barn. Now you put it on your barn or on your home, and you run the wire inside, and you can play Xbox and all the gaming features and everything because the latency is low enough. But also it provides 5 bars of cell coverage. So now your cell phone system works. And it's better, it uses less battery power because it's not transmitting at full power to get to the macro cell, so your cell phone lasts longer. When you get in your car and you drive away, it hands over from the one on your roof to the macro cell. So now we're enabling people to have full-on LTE high-speed connectivity anywhere in the world and be able to mesh in with the global phone networks. And we actually have a lot of telecom operators as investors, and so we'll be deploying around the world really as part of the telecom operators. Our terminals will be very small and very inexpensive, and will allow very high speeds. Eventually, we'll get to a gigabit per second. Initially, we're targeting 200 megabits per second. Coca-Cola is another investor. They've been fantastic. They have 39 million points of distribution. Like, where have you gone and not been able to get a Coke, right? So those rural areas, we've done a lot of testing on the need for having more things for the person to sell. And they've done some work where they've put Wi-Fi hotspots and allowed them to sell them along with Coca-Cola, and it's been fantastic for generating revenue for the small entrepreneur. The tests originally were in South Africa, in very rural areas. We've done a lot of work with schools because we're trying to, that's really the main focus, was to get some connectivity that would work on be self-installed capacity for schools. And I'll just take a little side jaunt here. Just recently, separately from OneWeb, and I invite everybody to participate in this, I funded, but we're going to welcome everybody to participate, a nonprofit called Project Connect. And the mission of Project Connect will be totally neutral. It's to map every school in the emerging markets so you know where they are, and also have a metric of connectivity at every school, meaning either a little dongle that's inserted at the school, that's inserted in the router so that you will ping back to our NOC, and you'll be able to see, really, you'll literally be able to look at any country, say Mexico or Argentina, or, and you'll see all the schools, and you'll see the ones that are, don't have connectivity, do have connectivity by color code. And will allow the government and globally to say, what's the minimum bar for connectivity? Because a big problem I notice in these schools is the government says, oh, we have 30,000 schools connected. You go to the school and they have 128 kilobits per second on some geolink, and like, it's not connected, right? So you need to set a minimum bar, maybe 10 megabits, maybe 20 megabits per second. But what we're learning is that you can extract a lot of data from this. So first of all, you get truth, right? Because the connectivity is there. It's either the router is pinging back to you or it's not. So you know whether it's there. You know about how much power that school has, because it's either working or not because of power. You can see when there is power, when there isn't power. And you can also see how much capacity they really have and what the latency is. So this is actually one hard, truthful metric that we're developing now for all the schools around the world as a NOC. And a lot of these markets, they really don't have the ability to understand how much capacity their schools have, how it's being utilized. So I invite anyone to participate and help. We'll need all the help we can get for it over at Project Connect. So that's a fun thing that's dear to my heart, because getting everybody connected to something we should all participate in, and we need a metric, an observable metric, to know that we did accomplish that task together. Back to a little bit about this mission, just something that you might find fun for first responders. It's another area that's important. So we can put a terminal on a truck, and they'll be very small, these things, and it listens to the AT&T tower, Verizon, whatever the tower is, and when the signal strength goes down, it actually turns on, so you don't drop a call. So if the cell towers go away, you still have coverage globally. And we're finding a lot of interest from first responders on that capability. And there's a lot of other technology that goes into this. Like if a fire trucks come together with police cars and maybe there's a disaster and the cell towers are gone, as they come together, they create a network. Every millisecond, it determines a new network. So it's really cool for them to be able to have continuous coverage, even in times of disaster. And this works in Papua New Guinea and Palau as well as it does in Pennsylvania. So it's really a global thing for everyone. And we're getting a lot of positive interest in this. This technology, a lot of it's from us and some of it's from Qualcomm, and sort of merging together to create these infrastructure opportunities. Airbus is a big investor of ours, and we're very involved with aviation, but that's sort of off topic. But we'll be doing trains as well, which was on topic. You're doing the train stations. There are 23 million people a day in trains in India. And getting connectivity in the train is really, really hard. So that's another aspect of the way our service works. And oil and gas is. So we bought our rockets. We bought them a couple years ago. It takes a long time to build this many rockets. They're getting ready and on station. We have 3 launch pads sites for us because things can go wrong, and we're going to be launching relatively quickly. We went with the Soyuz. It's the most reliable and boring rocket out there. You don't even hear about it. Like, no one talks about it. It doesn't get a lot of press because they launch between 20 and 50 a year, right? They launched 2 in one day, and it didn't even make the news, right? Because it's like, an Uber working. It just, so what? But I don't want to lose sleep, so that's why we went that way. We have a new factory we're building on NASA property down in Cape Canaveral. This facility will build 3 satellites per day. We have another one in Toulouse, France, which will be running 1 line. We'll be running 2 lines over here. We start production next year. We've got every piece of the satellite now has been tested. All the hardware, end-to-end validation of the throughput, end-to-end validation of the handover capability. We've got testing and testing and testing that's been done on all the components, and we're moving into volume production right now. So we're really close. We feel very confident and but paranoid because anything that goes wrong can be a big problem. So you have to really be dealing with every small detail. We have a great group of investors, and there's some that aren't even on here, the different groups that aren't listed here, but these are some of the ones that are well known. And they each have their own expertise that they've been contributing, as well as a lot of support generally. But from Intelsat and Hughes on the satellite side, some of the largest satellite operators, and Bharti is Sunil sits on our board. He was the founder of Bharti Airtel, which is the 3rd or 4th largest cell phone company. And Masa from SoftBank has been fantastic. So we've got a lot of momentum. Airbus has been really great. Tom Enders, the CEO of the group, is on our board and really enthusiastically supporting us. We got a long way to go. This is super hard, but we are methodically and boringly dealing with each aspect. We've got our user terminals all sorted out and how they work. And this is going to blow your mind. They're going to be handed out like hotcakes. They're so cheap. And then we've got our gateways, and our satellites are in process, and our rockets are going well. So everything is chunking along. And that's the good news. But something could break at any second. So we have to constantly be worried. But coming back to the mission, right? How do we enable connectivity for everyone? We need to build a network where people can deploy their own things. And so we want to empower communities to build their own networks. Make it simple enough to install your own internet. We don't have to go there. They can FedEx a terminal, put it on the roof of a school or a home or something, and anybody around that school can share that terminal with open access, as well as cellular operators can use it, as well as, of course, the home and the person who purchased it. So that's a bit about OneWeb and what we're doing. Thank you.
So I'm Robert Pepper. I'm at Facebook. What's great, Marion and Greg, we've met before. Marion, I don't know whether we have or we've been on panels together. But I think we could probably be interchangeable in the presentations, right? Because each of us are working with teams that are completely, the satellite piece is absolutely critical. To fill in sort of the gaps. But Marion, your presentation and we could probably have switched off because what we see is one size doesn't fit all, right? It's not about a particular technology. So the magic part of this is which is forward, which is backwards, right? This is the problem. This is like, oh, forward. Okay, we made it. Okay, so part of this is really, so I've actually, titled my part of this is identifying and filling the gaps. All right, to me, that's really crucial. And satellite is, and I'll talk about that, is absolutely a critical part of that because I knew Greg was here. I'm not going to talk about satellite. I'm going to talk about some of the other things. And Marion, you talked about these as well. So the Facebook mission is essentially to have everybody connected, give everybody the power to share, make the world a more open and connected place. Right? And we all know earlier the economic benefits, the social benefits. Manu did incredible work with Megan and folks on the Global Connect initiative. And I didn't know, but congratulations on your new gig. That's great. But part of making this work is aligning incentives. Right? We have to get people together. Right? And it's not about competitors. It's not either or. The answer is yes, it's all of the above. But figuring out where the different parts fit. And there's going to be a whole different, wide range of models. So, we try to focus on aligning incentives and benefits for all. Right? We're not a telecom operator. We want to enable them. We're not a vendor, although we have engineers inventing really cool things. The approach we take is open sourcing, making all of it available to anybody, trying to identify and fill those gaps. So we all know that, right, there's 3 billion people connected, but there's 4 billion people plus that are not connected. But what I try to think about this in a slightly different way, which is moving from scarcity to abundance. Because, there are people who actually are connected, but they're only sort of connected, right? They're actually underconnected. And this is some of the, is it the 2G issues? And is that enough? No, it's not. High latency, Greg, right? No, it's not enough. So you want to go, from 36,000 miles down to 1,200 kilometers, right? How do you get that latency down? So I think we need to be addressing thinking about it slightly differently, this abundance question. How do we really step up to not only more people connected at faster speeds, but I tend to think of these multiple dimensions of abundance, right? It's more people, it's more devices, it's more coverage, more diverse devices, more applications, and better quality and much more capacity. So it's not just it's not binary. It's not am I connected or not. It's think about the dial-up days, right? I mean, we were all thrilled with just getting on with text. In fact, I'll talk about what we're doing, just getting people on with a text-based service. But once you're on, you want to move up. You want faster. You want more. You want video. So it's really this abundance question, right? And we need to think about that as we think about and trying to identify where are the gaps and how do we fill them. So the way we've analyzed it, in a very methodical way, very similar, Marion, I mean, you could have given this presentation. What are the connectivity barriers, right? And connectivity is about getting people connected, right? So there's availability, there's affordability, and then there's awareness, relevance. So focusing on the availability, right? You actually had two different artists did the same slide, right? It's really remarkable as I was watching you, I was saying, okay, I'll know what you'll say next year. You can fill in for me. We can pick up for one another. High density, medium density, and low density areas. And we can look at different solutions. Satellites are terrific at the low density as well as some other things. So I'm not going to talk about satellites because I knew Greg was here and you did some great stuff with O3B and now OneWeb. It's all really very cool stuff. I'm going to focus a little bit more on the medium density and even the high density areas where there's not the kind of connectivity that we need. So the unmanned vehicles I'm going to talk about, FSO is free space optics, using lasers to connect things, millimeter wave, and then terrestrial. So we have these, we are identifying, we have an incredible team of engineers. I tease them that they're turning science fiction into reality. And so we have projects with these engineers in our connectivity labs looking at dense urban areas. How do you actually bring fiber-like connectivity in high population areas like the high density areas in Mumbai or any large city where it's unlikely that there's going to be fiber soon. We have projects looking at the medium density. I'm going to talk about Aquila, the unmanned vehicles, and then low density where there's really limited or no connectivity, and then it's satellites, especially the low Earth orbiting. And again, thank you, Greg, because that makes it easier for me. Terragraph. Terragraph is a project focusing on high density areas. How do I get fiber-like connectivity as backhaul, right? Not to necessarily the end user, but as one of the biggest barriers to high quality, abundant internet connectivity is backhaul, right? A lot of talk goes into last mile access. But even in the US, right, when the FCC had its broadband report and the analysis, the UN Broadband Commission work, a lot of the work, we know that one of the biggest barriers is backhaul and middle mile, right? We can have cell towers, we can have 2G, but how do you upgrade to 3G, even if you put the antennas on the towers and you have the power and the other things, if you can't get backhaul? On the earlier panel, there was a question about fiber, right? Greg points out, trenching is like really hard, right? So how do we get, so Terragraph is designed to solve the urban bandwidth challenge in high density population areas, large urban areas, especially in the developing world. Right? And it's using very small nodes. I remember when I was at the FCC, we opened up the 60 gigahertz band called the oxygen absorption band. Oxygen absorption band because oxygen molecules absorb the energy at that frequency. It would only go, therefore, the signal only goes a very short distance, right? And people say, oh, but you want long distance. Well, not if you want a lot of reuse. So in theory, right, you could reuse, reuse, and reuse with very small cell. That was a while ago we opened it up. The problem was, in order to do that, you needed very high processing speeds, right, at very low energy, right, and that at a low cost. That was not actually possible until very recently with the chipsets that have come down in price and energy consumption. And we're not the only ones working on this. There are other companies working on small cell as well. But what we have looked at, and the way we're looking at this, is to have networks that are going to use very small cells, software-driven, with computer power to bounce off of buildings with beamforming to enable fiber-like backhaul connectivity, middle-mile connectivity for backhaul to anybody. It could be to mobile operators, it could be to community Wi-Fi, but not necessarily to the end-user device. So that's one of our solutions. Aquila. Right? This is very similar to loons, but instead of balloons, what we're doing is designing a constellation. You're designing unmanned vehicles to fly at 20 kilometers with a flight radius of about 2 to 3 kilometers, solar powered. The first one, we had the first flight test last June. It was supposed to fly for 30 minutes. It flew for 90. We're now taking terabits of data from that, and we're building the next one. So the idea is these things have a wingspan of a 737. They only weigh about 440 kilos. We have people working on new material science, solar energy. And we're also, it's not just flight test, but we also have payload testing. So in parallel, we're testing payloads. We're building and testing the flight platforms and building and developing the optical links. And so the way this is going to work is, and what you can see here is that there will be a ground station, right? This is in a city, but it also could be a fiber landing station on the coast from an undersea cable. It would then beam up by using radio to one of the Aquilas. And then there will be dozens or even hundreds of them that are going to be meshed together with laser beams. And when they get over a village, they will beam down gigabit Ethernet as backhaul. Right? And it's not being designed to go directly to end users. So it's not going to be sort of at this point, an LTE, big LTE antenna. So it's slightly different. But it's going to bring backhaul to mobile operators towers or community Wi-Fi access points. And the idea is not to be an operator, but rather to make this technology available to anybody, including operators, to be able to get the backhaul that they need to solve this backhaul middle mile problem. Because without fiber-like connectivity, right, and satellite is going to be doing a big chunk of this, where there's fiber, that's great. And by the way, one of the nice things about balloons or satellites or Aquila is that if it creates enough demand in a particular area so that there's a business case for pulling the fiber, guess what? Things that fly around can move, right? And then you can repurpose them someplace else. That's one of the really nice things about things that fly around, right? It's not the traditional sunk cost network here. You're not then going to say, oh, I'm going to pull this up and dig it up and move it someplace else. That doesn't work. So those projects were really focused on maximizing, finding the gaps in availability and infrastructure and filling them. Affordability. When we talk about affordability, we tend to look at or focus on universal service subsidies or end users bringing the cost down at the user, consumer, citizen, right? And that's very, very important. But we're also looking at it from the flip side. How do we reduce the cost of the technology so that the operators can reduce their operating costs and therefore lower the prices? So that's a really important part of the affordability equation. So we created with a number of other companies something called our TIP, or Telecommunications Infrastructure Project, which is engineering focused. And these are just some of the members within the TIP group. You can see it includes vendors like Nokia and Juniper. It includes a lot of the major mobile operators around the world. It includes, Intel and other chip, silicon companies. And the idea is to dramatically change the cost structure of these networks and bring those costs down. And we developed this based upon our open compute model, which was designed to dramatically reduce the costs of computing. And if you can do that, you reduce the costs, in this case, of the network. And if you reduce the costs of the network, both in CapEx and OpEx, then you have the ability to reduce the costs and the prices to the end user. Right? So we need to think about cost reduction in multiple ways. And I see Vanu nodding. What Vanu has done, and Greg, I don't know if you were here for Vanu's discussion about Vermont, because Vanu talked about Vermont as well, trying to change the cost curve on the network side in rural areas. And then finally, awareness. So we do know that there are a lot of people who could subscribe, who can afford to be on, but they don't see a reason to connect. Right? And so this is clearly part of the demand side conversation. So, and some of this is awareness. So we developed this project you probably have heard of. It's called Free Basics. If you think about it as sort of a skinny version of internet access, right? Effectively text, right? Think going back, some of us are old enough to remember early days of internet. I know Nen was here earlier in the morning. But then, having that introduction. So we developed the project called Free Basic, right? So and as it launches, as people get on, we have partners. Again, it's Marion's right. It's again, it's about partnering, and it's about creating an ecosystem. It's creating an environment, working together. So we have over 60 Free Basic projects around the world. It's non-exclusive. So we have over 78, I think it's about 78 to 80 mobile operators that are partners. It's open, non-exclusive, and any content provider that meets the sort of skinny technical requirements, which are transparent and published, can be part of the Free Basic platform. And it's essentially a skinny version, a text-based version of the internet. Again, think back to dial-up days. And what we're finding is that when people get introduced, just like we did when we first got on, we want more. We want higher quality. And what we're seeing is that as people become aware of the internet, have experience using it as an introduction, it becomes an on-ramp. And a significant number of people convert from this skinny service, which is free. By the way, no money changes hands, right? Facebook does not pay the operators do not pay Facebook. There's no money changing hands for this. Some people don't understand that. But what we see is that people actually say, I want it and I'm willing to pay for it. And people actually convert into paid subscriptions because they want the pictures. They want the video. They want the images. They want to be able to download faster. And that's part of this. It's creating the awareness. It's an introduction to the internet. And then, beyond that, there are other variables when it comes to readiness. Local content in local language. Antonio, this is what we've worked on together in the past. So those are just some of the things that we look at as we try to identify and diagnose the gaps and have very specific projects designed to fill those gaps so that we actually can move from 3 billion to 7 billion people connected, in which they are seeing real value to being online. Thank you very much.
All right, here we go. Cool. I'm going to sit down and have this all behind my head. It'll be quicker whenever we all actually get up on the stage. So my name is Paul Garnett. I work for Microsoft. I run something called the Affordable Access Initiative. So first of all, let me just begin by explaining to you a little bit about Microsoft and why we're so interested in this whole space, and then I'll talk a little bit about the Affordable Access Initiative and some of the work we're doing there. So from a Microsoft perspective, behind me is a picture of Satya Nadella, our CEO in Kenya, at a project location, and our mission statement, which is to empower every person, every organization on the planet to achieve more, which is a very big kind of technology company kind of statement. Our sort of original mission statement was sort of for the kind of almost sort of before the internet, which was basically basically the idea was a computer on every desk and in every home, right? Microsoft's really been a company focused on productivity for people for years, and we're now shifting to the cloud era, where basically services and applications will be delivered from the cloud. They will not necessarily be on someone's desktop. So ideas around connectivity become all the more important for us. So when we look at the issues around affordable access, where we've talked a lot about this today, 53% of the world's people are not online. We literally can't serve these customers if they're not online, right? I mean, there's no connectivity, there's no cloud. And then you talked about this issue of, well, even for those people who are connected, the 3 billion who are online today, maybe bandwidth is too expensive for them, and they're rationing it. So then they're effectively, I mean, even though they're technically online, statistically, effectively they're not. So as a company, we're very motivated to see if we can figure out ways to change all that. The area that I work on is affordable access, but we're doing a lot more than just the small area that I'm in. So we talked earlier about things like data centers and submarine cable landing and submarine cables and landing spots and things like edge nodes and networks and caching. These are all other areas that we're involved in. We're making big investments there. But then there's this issue of, okay, great, we've got submarine cables, ringing Africa and crossing the globe. We've got data centers that are going in various parts of the world. Governments have made huge investments in fiber infrastructure to get the backbones into networks, into countries, but then we're left with no middle mile, no last mile, or a set of technologies that may not necessarily work for the populations that we're talking about. So we're very much focused on partnering up with different types of companies through the Affordable Access Initiative to figure out new innovations in technology or business models that can help more people get online. And we've talked a lot about internet access today, but power is another area that we've also touched upon. And basically in sub-Saharan Africa, for example, you have 1.2 billion people around the world who are don't have electricity where they live, and a lot of those people are in sub-Saharan Africa and South Asia. And then about 2.5 billion people in the world don't have reliable electricity. So you can't deliver broadband access if you're not tackling these other issues. Other areas that we're looking at are payments. So of course MasterCard is your new employer is very interested in this space. Most people in the world don't have credit cards and bank accounts. So we have to figure out other ways for them to be able to pay for services. And they don't consume services in the same way. Most of the world is not on subscription and postpaid. They're on prepaid and small chunks of consumption. I was just at a board meeting last week with one of our partners in Kenya, and one of the things that we're seeing is the smaller the increment, the more revenue you get, right? So even though it actually would make sense from a per gigabyte consumed perspective for someone to be buying the bigger package of a prepaid package of data, they're buying the 50 shilling or equivalent of 50 cent 300 megabyte package because that's the thing that they can afford on a daily basis. They buy in very small increments. So it's really trying to tackle all of these issues. So in terms of what I do, here's the map of the world and the dots and all the countries in which we have projects today with different types of partners. We're heavily in Africa. I have been lucky enough to work with a lot of interesting entrepreneurs in Africa. It's an amazing place to get projects going in. As Greg mentioned earlier, it's a toolkit approach, so we're not religious about this. It's not necessarily one thing or the other. So we're just looking at the cost economics of delivering data to customers and figuring out what's the cheapest thing for the market. And what we want to be able to deliver. Satellites certainly is a piece of that equation. Generally, what I'm seeing is terrestrial is still king. If you can get to fiber, that's still what you want to do in order to deliver access. And we're doing a lot with unlicensed technologies like Wi-Fi, TV white spaces, millimeter wave technology. We're very interested in doing more on 3.5 gigahertz. So yeah, really just try it anything, right? The other thing is that the projects we have today are fairly small scale. These are a lot of times either kind of seed projects or at scale. More of them are at seed than at scale, and a lot of it's just working with little entrepreneurs in countries around the world and figuring this out with them. At the bottom of this slide, I have a sort of boxes on kind of focus on the education vertical, because that's one that we often get focused on, because whenever we talk to governments around the world, the thing they care the most about is education and getting kids connected. So these are just examples of just some of the impacts we're having. And I think oftentimes, when we're having a conversation like this in a place like Washington D.C., we're very kind of remote from the impact. And one of the great things is actually getting on the ground, get your shoes dirty, and go into these rural areas and meet people and see what kinds of impact you can actually have, and it's amazing. So on the seeds side, there's a program that we launched last year, our Affordable Access Initiative Grant Fund, which is very focused on partnering up with companies that are kind of in the seed to Series A stage. They're trying to bridge that gap. And one of the biggest issues, especially in emerging markets, is access to capital and being able to sort of prove out your great idea. So we launched a program last year focused on affordable access. We were able to give grants to 12 companies in 11 countries on 5 continents. So great geographic diversity in terms of solutions, so anything from hardware to connectivity to applications, and with a particular focus on 3 verticals: education, agriculture, and health, which are really, especially in emerging markets, really key important verticals in those markets. We just closed the window on this year's grant program. The response was incredible. We had about 450 companies, get on the tool and start the application. About 220 completed. I think the quality of the application, is based on what I'm seeing, is even better than last year. And now we have the hard task of going through all those applications and figuring out who we're going to be fortunate enough to work with on projects. So I feel like, especially given we're in Washington, D.C. and we're near policymakers, I feel kind of a little bit like I have to talk about TV white space, because this is an area that we've done quite a lot with as a company over the last 15 years at Microsoft. I mean, some of our researchers were involved in this technology early on as they were looking at cognitive radio systems and software-defined radios in this whole emerging area, which now we're seeing in other bands as well, not just TV white spaces. And oftentimes, I get sent a blog or two that's been written by some DC lobbyist who really doesn't know what they're talking about. And it's always a little bit of like, you've told me my baby's ugly, so I have to kind of defend myself a bit. So one of the things I just want to say around TV white spaces, because we've done a lot with it, is it works really well. It's great for rural deployments. Basically leveraging the propagation characteristics of UHF, and actually we're going to see VHF radios soon. It's a technology that's already cheap, even not at scale. So if you look at it compared to something like LTE on a cost per gigabyte delivered basis, it's already cheaper, basically under any scenario. It's also something that is we can take advantage of existing regulatory harmonization we already have globally, because we already have broadcast bands and we operate on a secondary basis. And then the other thing is it doesn't cause any harm to anyone. So in all the projects that I've been involved in anywhere on the planet, whether I'm in an urban environment or in a rural environment, no broadcaster's ever been interfered with. We never had a single complaint from anyone that anything bad happened. So don't worry about that. So it's all good, and we're going to be doing more with the technology over time. And that sort of gets me to the ecosystem piece, which is something I work quite a bit on, and we are doing a lot to sort of get that ecosystem going from a technology perspective. So the pricing will come down over the next 24 months. So I'm going to quickly, just very, very quickly touch on a few different projects, in part because I just want to kind of talk a little about different scenarios. And we talked a lot about emerging markets, but of course we do have emerging America in a way. And there are people in the US who don't have broadband access, or it's not affordable for them. I think it's 34 million Americans do not have access to broadband, and the number, of course, is much higher from a subscription perspective. So one project that we're doing right now, which is kind of a proof of concept project, is in Southern Virginia, where we're leveraging fiber that's already going to schools and using TV whitespace technology to extend connectivity from schools to kids at home. So these are communities in Southern Virginia that are lower income on average, more rural on average, so therefore less connected. So approximately 50% of the households in these 2 counties we're focusing on initially don't have broadband access. So we've got fiber going to these schools that has been delivered to these locations by a great company called Mid-Atlantic Broadband Communities. This is fiber connectivity that has been subsidized by the E-rate program, part of the universal service programs in the US. And we're using TV whitespace to essentially illuminate coverage in these 2 counties. And just by virtue of basically getting connected to the fiber at the schools, we're able to illuminate coverage across both of those counties, so that we can have connectivity pretty much everywhere. The reason I highlight that in this context is because whereas in emerging markets often the issue is going to be about getting connectivity to a school, in the U.S., more often than not, I know there are a lot of schools in the U.S. that don't have good connectivity today, which is shameful. But the scenario in the U.S. more likely is going to be how are we going to get connectivity to someone where they live. You've got these anchor institutions that have connectivity. How do we avoid the scenario of the kid having to go to the library to do his or her homework, or look for a Wi-Fi access point, or go to McDonald's or something like that, and have to do it and really kind of help to close the homework gap. So that project is in deployment right now, and we should see some good impacts. And then the next two I'm just quickly talk about. One is in northern Namibia, in a very, very rural location, and off-grid location, very low population density. And we're partnering up with Millennium Channels Corporation and a company called My Digital Bridge to bring broadband access to schools there. And here I just wanted to highlight this project because of just the propagation characteristics of TV white spaces. So you can do networks over very, very large geographic areas using this technology, and get connectivity to places that otherwise wouldn't get it. Maybe these would be places you'd otherwise do with satellite, if not for something like TV white spaces. And then the other one I just want to mention is Jamaica. This is another project around rural access. And part of the reason I want to highlight this is because of this right here, which is basically TV white spaces. So you can see in a place like Jamaica, the two red channels are basically the only two occupied channels in the UHF in Jamaica. So you have basically channels 17 and 21. That's in Kingston, so that's the capital of the country. So that's the most urban place in Jamaica. 2 TV channels occupied. The rest of it's completely empty. So this is spectrum abundance if you're ever going to see it, and is a great sort of scenario for TV white space access. And we see this often in emerging markets, whether you're in an urban area or in a rural area. This is not like the New York City media market, where most channels will be filled with broadcast. These are places where you have a couple channels that are filled with broadcast, and the rest of it's just green, empty. In other places in the Caribbean, there's no broadcast. So when we're talking about emerging markets or rural America, these are technologies that we should absolutely be looking at taking advantage of. And with that, I guess we're all going to get up here and answer a couple questions. Thanks.
So the panel should come up. I, of course, realize we're running over, but for some of you maybe weren't here at the beginning, we started a little late because of weather. So we'll have a quick panel discussion and then adjourn.
Okay. All right, thank you so much for showing us a lot of different stuff that's going on by each of your companies. When will these projects, do you think, when will they meet and reach larger audiences, larger populations in developing countries? Lots of activities going on. All of your companies have been doing this for years. Maybe Facebook a little earlier, a little bit more recent. When do you think that these projects will reach the audiences that you hope to reach, the larger audience? We'll start with you, Marian.
So I think the project that we're doing in India is a demonstration of being able to reach hundreds of millions of people in a very short period of time. Project Loon, of course, is more of an experiment, so it's a moonshot that will take maybe 5 to 7 years. The project that we're doing in Africa, especially since we're doing it in partnership with others, I think that will have a much more rapid expansion and be able to capture, again, a significant number of people that are now offline.
How about on your satellite project, Greg?
So we are on our timeline. We launch next year, our first satellites, and 2019 we're going to turn on service. So you'll start to see tens of thousands, and then in 2020 hundreds of thousands and millions of people moving up to eventually probably 1 billion people online in 2025. So as we continue to launch, we don't have a test. Right? There's too much energy, too much infrastructure you're building. It's all or nothing. You're putting it up there, and you're going to get a lot of people on immediately. So they'll just put the terminal on and they turn on and you're good to go. So
2022, you want to reach every school, you were saying?
in 2022, we want to have every school in the world.
And you're telling your investors, excuse me, besides schools, what are you telling your investors in terms of reach after you light it up?
Well, you saw some of the, so the way satellite works is there's this sort of $10 billion market of today that exists. And it's basically your customers all have three things in common. They're desperate, they're willing to pay too much, and they'll accept really junky bandwidth. And so that's a $10 billion market. You're on a plane. You pay $20 for 2 hours. You wouldn't pay $20 every 2 hours at your home, right? And it's got high latency and it sort of works in some things. Your VPN doesn't work, things like that. Right? You're on an oil rig. You're desperate. You have money. So that's a $10 billion market that we'll go into for sure. Yeah. But then there's a whole nother market, the three infinite markets, which is cellular backhaul, direct-to-consumer, and connected car, which we'll be serving as well. So you'll see us initially, a lot of the $10 billion market that's out there today will be picking up, and you've seen announcements from some different players like GoGo and the like that will be using our capacity, and Intelsat, a lot of partnerships with them, and Hughes. But then you'll see a migration, or very quickly you'll see a lot of residential and municipality, school, custom center, police station, places like that connect on.
And Robert, you're saying that not one project is a solution for all. There's a lot of different ideas that will work for different scenarios. But you'd like to touch a lot of numbers of people, big numbers of people. So what is your thinking about when you can?
You look at the different gaps that are being filled. So over the next, a project that I did not talk about was something called Express Wi-Fi. Similar to the project that we heard about in South Africa, but we're already implementing that in trials in countries ranging from South Asia to India to Africa. It's already connecting tens of thousands of people who were never connected. We think that's going to move very quickly to hundreds of thousands and then to millions. But that's sort of for medium density outside of cities. And how do you get that kind of connectivity? So again, very specific types of solutions for very specific kinds of gaps. Like Loon, Aquila is longer term, several years, but it's similar to satellite. Once you actually have it and it's there and you turn it on, right, then it's going to scale very quickly, especially as a backhaul technology. Mm-hmm. Because there are lots of network operators out there that are there, but they can't get the broadband because they don't have the backhaul. So any of the backhaul technologies you're talking about, that we're talking about up here, as you connect then at an access point that then opens up all of the existing customers, so it's almost flipping a switch and it's hundreds of thousands or millions at that point for any of these backhaul technologies. Mm-hmm. So it's all of the above. And so it's not waiting. It's already happening. And then once you get to that sort of tipping point, it instead of like this, it's just going to go vertical.
And Paul, do you have a sense of when you'll reach large populations, a target that you can tell Satya and others?
So it really depends on there are all kinds of disruptions happening, right? So I think if we're talking about something like submarine cables and data centers and edge nodes having an impact on the cost of bandwidth, that's already happening, right? And all of our companies are involved in this, and these are multi-billion-dollar investments, and so that's happening today, right? When we're talking about some of these last mile access technologies, like let's take specifically something like TV white spaces, we validated for ourselves that the technology works well. We validated for ourselves that from a commercial perspective, it's something that is a good input into a network. Really, right now, the challenge is driving down the cost curve in terms of the cost of the technology, right? So, once you get down that cost curve where you're basically at the price of Wi-Fi, then it's going to take off, and I think it's probably 24 months away on that.
On that.
Yeah. So we'll see the first ASICs this year, built on silicon TV white space radios, not standards based. But cheap, and will make deployments much easier. And then next year we'll see Wi-Fi.
Cecilia, just one more point. I think if we did have an initiative where we were all working together, I think the answer to your question would be a lot faster.
You know, and that makes me wonder, you are all competitors in some ways. You cooperate in other ways as well. You have proprietary projects. Can there be cooperation? What would that look like?
Yeah, and I think at this level, at this base level, we all share the same passion. So I think we can overcome that competition and figure out a way to jointly form forces.
And where would you see that? On the technological development, on the dealings with regulators? And Bob, you spent much of your career dealing with regulators.
So a good example of that was at WRC 15. Facebook and Google partnered together to propose, and actually the US and other governments were great, something called High Altitude Platform Spectrum, HAP Spectrum, and so we cooperated on that, recognizing that we have we're developing different solutions to solve the same problem, but we both need to have access to that spectrum and do it in a way that will not interfere with satellite. And that's moving forward. So, you cooperate on that. And again, we're very agnostic about this, right? If somebody has a better solution that can do it, great, right? So if we develop the technology and we're open sourcing it and giving it away to others to be able to use and operate and to create, consortiums that might want to fly constellations of the Aquilas, that's terrific. So I think, and you already are beginning to see those kinds of cooperative arrangements building out this ecosystem. You have some of the internet companies up here working in partnership with traditional telcos on backhaul networks, right, to connect data centers in places where there are no backhaul networks. So we're already seeing that.
Paul, any thoughts on that?
Yeah, I mean, my experience is it certainly happens in the policy space. I think we're largely aligned on a variety of different issues. I mean, maybe sometimes we stress things a little differently, but I think at the end of the day, when it comes to talking to regulators or going to the ITU, there's a lot of commonality in terms of what we're saying. And then likewise, I think in the technology standardization space, I think we see a lot of alignment there as well. When it comes to collaborations on pilots or deployments, or you start to sort of get more into the commercial space. And I think there are opportunities for collaboration even there. But at the end of the day, we are competitors, and when we get into that, it gets the conversation gets a little more difficult, and there will be situations where we do things that are in competition with each other.
Well,
it's just the nature of the market.
they're all
That's okay.
They're all competitive. Well, and that leads me to ask you, Greg, do you think, this is your business, this is everything, this is the pie, it's connectivity.
That's it.
For these other guys, this is a project that's important, really long-range thinking to just the thriving of the internet and thinking about your businesses long-term. But it's not what's making the most of your revenue. So how do you, I guess the question is, would you be able to partner? But also for the other companies up here, how do your companies think of the returns on these projects and the value of them? So maybe I'll start with you, Greg, and then I'll ask you guys.
So we are and are totally open to partnering with everyone here. I think the reason they're doing their thing and the reason we're doing our thing is because there's a problem. Now, I think magically, we'd all wish the problem went away, we could solve it. I think all three of their businesses would be better if the pipes from their headquarters was open 100% free-flowing data to every human in the world, right? All their businesses would grow dramatically, and they would be working on other things. They're doing it because there's a problem. I've sort of done this because of an internal clock inside me that has this mission. And so pulled together a lot of resources, spent a lot of time in every single aspect of what they're doing, like my knees in mud, trenching. And I think we have a technical solution, I know we do, that will meet some portion of the need. There'll be other things. We're not going to beat up fiber or better than fiber. But the market's so large, there's room for many different technologies and topologies. I don't see it as competition. Like I said before, it's not competition. Someone wants to run fiber, good, have at it. Because there's just no way. We'll just take the last pieces on the end. We'll solve all those problems. So we'll work with them. And how can we work with them? In many different ways. For instance, at all of our gateways, putting their content at the gateways, making sure it's available for consumers on the other side of it. It helps all their business, and we're spending the money to make the pipe. So we're really open to working with everybody in a positive way. Even people who theoretically are competitors and want to run fiber, again, we just say, go, please. It's good for us too.
Yeah, I think what you heard from all of us are a range of different activities we're involved in, anything from things that are kind of more short-term to longer term. But I can tell you that there are deals we can't do in emerging markets because of lack of connectivity. So if we're having a conversation with government around getting kids laptops, and 2/3 of the schools don't even have internet access, it's almost like, what's the point? So these are issues that have to get solved, and they are deal blockers today. And so there is an urgency for all of us to try to address these very practical issues. Of course, we are all involved in longer-term projects. I mean, Microsoft has a massive research organization, and there are plenty of folks working on some very cool issues there. But that's not the place where I play. I play more in the kind of get deals done today and business development partnership type stuff around access.
And I sort of touched on this in the earlier question. How do you, as three, Microsoft, Google, and Facebook, publicly traded companies, think about value and the return on these projects?
So for Google, as you know, the main mission is to provide universal access to information. So if we don't have an underlying network infrastructure that can do that well, then we have no business. So what we've done is to deploy and help stimulate the growth of these networks at little or no cost to the actual consumer. And what we hope to do is at one point reach a sustainable business model and just cover our costs for the underlying network infrastructure and not actually create a profit on that.
They're not seen as profit generators, but at some point they've got to
be sustainable.
make up a sustainable.
Yeah.
I mean, the business model requires connectivity. Without robust connectivity, if you're providing applications and content up the stack, and there's no connectivity, you don't have a business. So it's we don't make these technologies to sell them. We're not vendors. We don't make these technologies to sell as a service. God bless Greg that he's doing that, right? If he's really successful and the costs come way down, then we don't need to do what we do because, right, you're going to be doing a lot of that connectivity activity. So the business, it's a different business. Microsoft is not a vendor either, right? You're doing these things because you have to for the rest of the business. But there's also another part of this that, actually all four of the companies, I mean, there is a genuine passion within the companies to connect the unconnected. Either the founders, or in the case of Microsoft, your current CEO. This actually is top of mind as a passion, and it's part of doing well by doing good, because it creates this virtuous cycle. If everybody's connected, right, that's the right thing to be doing in terms of social, economic benefits, growing the global economy, et cetera. But also, it's good for business. These are not mutually exclusive.
So I'm just going to say, in my case, I kind of slice it in three different ways. One is very transactional. So is there a deal that's in front of us right now where connectivity it needs to be an element of the deal that we have to solve, right? The middle is more kind of business development partnership type stuff where we have a longer horizon, maybe a 3-year horizon or something like that, and we're looking but we are still looking for profitability both for ourselves and our partners, right? We need this to be sustainable. And then there is longer term stuff where it's proof of concept or something more in the kind of CSR space where we're going to make nothing off it anytime soon, but we think there's some potential in the future for this potentially to turn to something that's commercial. But there is discipline around all of this. Yeah. It's not like we're just doing this for the heck of it and because we care about it. I mean, all of us care about it, right? But we also all happen to work for for-profit companies, and
it's good for business.
We've had to have insane discipline because I've got Qualcomm and Airbus and Intelsat and Hughes and these extremely technically savvy companies with their CEO and chairman on our board, right? So before they invest and get involved with us, they are digging through every aspect, from starting with spectrum, that's number one, and then they dig through the rest of it to make sure it's all working. And so we've had that as well as a business model on the other side. To raise this amount of money that we've raised, it requires a very strong business model. But I think at the end of it, we can have a step function change in the cost of bandwidth and the quality that's accessible to the other 3 billion. So that's the other side of the horizon, or over the horizon, that we're looking at, and all of our investors are looking at.
You know, speaking of spectrum, Greg, do you have the spectrum that you think you'll need?
We start there, yes.
You start there, and maybe, you know, more specifically, the FCC in July had their frontier order where it opened up large band of spectrum, satellite spectrum for sharing with wireless providers for 5G.
Yes.
Will you and others that are trying to do what you're doing, like SpaceX, will you be able to share that bandwidth?
Well, so there's a bit of a, see, we live in this, we're in the, as you said, we're in DC, and you're far from like the world. You know,
the whole world tends to be looking at us right now for some reason. I don't know why, but,
right, yeah.
but that's true.
The FCC is US.
Yes.
There's these other countries
Many
out there,
yes.
right? If you spin the globe, right? So the FCC, the US is like some small percentage of the total world. So the FCC is actually managing the spectrum aspects for a small percentage of the total world. The rest of the world follows the ITU. The FCC, for some historical reasons, doesn't follow the ITU in some things. So it's the only country in the world that does that. So we have the priority rights, and others have secondary rights beyond us, and the like. But we have the spectrum we need on a global basis. And then the FCC, in that, what you're talking about there, what they did was they took a 28 gigahertz and they said that we want to use that for 5G.
Yeah.
And that has no negative effect on us.
Okay.
Has zero impact on us because we cooperate very easily with that. So that is not an issue. The FCC largely follows the ITU, but you know, it's the US and they have their own rules.
Great. Marian, I want to talk about something specific to Google too. Google Station, which is your free Wi-Fi at the Indian rail stations in India that you explained a little bit, it's been pretty popular. Is there enough, and that a lot of that was due to the fact that, as you explained, fiber was laid along the tracks. Yeah. And so you do have the backhaul necessary. For that project to expand to other parts of India, let alone the rest of the globe, you do need that kind of infrastructure. What's the picture like for you for that kind of backhaul to make that project grow?
So we're looking at other countries to see where the fiber exists, and we have heat maps to help us determine that. Where they don't exist, we have another initiative that's underway called the Digital Highway, which is a prelude almost to a prelude to actually laying G fiber, and it's or G station, and it's looking at ways to stimulate the growth of fiber networks in these other regions. And we just got back from a fact-finding trip in Southeast Asia, where we looked at Myanmar and Vietnam and Cambodia, and we'll be going across the emerging markets, looking at other countries where there isn't enough fiber and enough backhaul, and trying to have a plan in place so that 2 or 3 years from now, it will be there and we can bring G Station to those countries.
And Robert, you talked about the success of free basics currently in many countries, dozens. A little bit further out there and more on a trial basis is Aquila. Experimental, but very exciting. Can you talk a little bit about bringing those to the US? Is that a possibility to serve the 34 million who aren't connected?
Yeah, anything, right, is possible. And we're constantly looking at lots of places for these things. I think if you look at some of the questions in the US that are really important, how do you get connectivity, again, not underconnected, but fully connected, in rural America. I mean, what about Montana, Wyoming, places that are very low density? And some of these new technologies, as they evolve and they're, they prove in, that's, also possible. But that's not sort of where we're initially looking. But yeah, there are large portions of the U.S. that are underconnected.
Absolutely. And you were talking a little bit, Paul, about your Virginia pilot in Southern Virginia on the white spaces trial.
Yeah.
And you're saying that 2 counties right now are blanketed
Yeah.
from the fiber nodes at the schools to
Yeah.
the homes.
Yes.
Can you tell us a little bit about what you found and how that project could be expanded? What are some of the, maybe the hiccups or some of the successes?
I mean, well, first of all, anytime you're deploying a new technology, there's always going to be hiccups in terms of delays and when radios show up and stability issues and all that kind of stuff. But I think the good news there is that all of that's now been ironed out, and the macrocell network has been deployed, and now we're doing the in-home installations with our partner. And we had basically we focused on one school first as our guinea pig and had about 60 households on that network, and I mean, they love it. I mean, of course they do. I mean, they haven't had internet access before, and now they can be online, and their kids can do their homework, and so all of that goodness. And then the question for us is the cost economics of it, and is this something that can be replicable across the U.S. and potentially in other markets as well? And that picture is becoming clearer, especially as we are able to deploy cheaper consumer devices. But the thing that's interesting about it is already, I mean, even as we're deploying it, the Commonwealth of Virginia has been very interested in the project, and other state heads of education are watching. And even we're even going to do a project in Taiwan where they have a similar problem. So similar kind of developed market scenario with a certain percentage of kids who don't have internet access at home, hyper-connected society, but facing some similar challenges. And so we're going to do a pilot project there with some partners. So I think the goal is that proof of concept, let's see if this works, and then let's try to see if we can essentially copy and paste this all over the place. I think the other thing I would say on the U.S. is, this was something that kind of we started focusing more on about 1.5 years ago. I think I had enough frequent flyer miles in Africa and decided, okay, let's see if I can take some of what we've learned in emerging markets and apply it to the U.S. And so I think over the course of this year, you'll see Microsoft announce at least a dozen similar projects around the U.S.
Right. It's about a business. I mean, the technology is proving in, right? It's really about a business case at this point in the business model, right? Mm-hmm. Can you bring your costs down? Can you get the volumes up? Does it make sense as a business case, right? And that's exactly. Really, I think, what you're beginning to see. Now, Paul's projects are further along than some of ours, but that's ultimately where we're going. I mean, and Greg's already made the big bet. I mean, you're making it a business case, right? You're doing the deployment. You really are, like up to your eyeballs, right? So
no
I mean, but
It's a moment of truth.
Yeah. But that's what it ultimately is about. Because is it scalable and replicable? And if it is, and then what happens is you can really drive those costs down the cost curve. Then it becomes the sweet spot for deployment in very low-income developing parts of the world because you've already gone down that cost curve.
Right. I think we have time for some questions, and there's a microphone. If you can please identify yourself by name and organization. Appreciate it right there.
I'm not sure I expect an answer to this question, but it seems like each of you has a different set of capabilities and a different set of technologies, and you're all looking for ways to show that technology will create huge impact in very distressed, poor, inadequate resource areas. Is there some pre-competitive way that we could find the best scale opportunities in the areas of solving those problems and bring them to you and have you say, that's one where if we leverage that with our technology, it would just explode a set of impact in India, in Uganda, in Kenya, in Tanzania. And then if it works, when we go to the next project, we already have a set of, in essence, enterprises that are sustainable on the ground that can move with the technology. And there are some that will have huge connectivity improvements If they don't do it with you, they'll get a 10x. If they do it with you, they'll get a 100x. There'll be others that, knowing that they have access to that particular technology, will design their solution to optimize for that, such that they get the 100x instead of the 10x by just getting in ahead of time and knowing the group in India that runs 53,000 single teacher schools. Which of your technologies would be optimal for those schools and the next 50,000 they're going to create in the next 10 years? Is there a way to pre-competitively get together and put you guys together with those people?
I think Google would welcome that. We're doing that internally, but definitely if we could collaborate with others to do that, that would help us tremendously, because we're trying to move as aggressively as possible. And if someone could lay that landscape for us, it would be with us. That would be wonderful. We would welcome it.
It's fine with us as well. I mean, I would want to say, though, is although each of us has our own projects that we're working on, it's not as if I ever do a network that's just TV white spaces. I mean, even a so-called TV white space network is going to have a whole variety of technologies that are inputs into it. So, or even satellite as backhaul. So it's, you know, we have a particular background in this technology because we helped to develop it. But you guys have particular backgrounds in other technologies, and I think it's a toolkit approach at the end of the day. So, yeah.
Question in the back?
New America. So first, two connected questions. First question is, as you build this connectivity, how do you ensure that you're not creating unforeseen problems of cybersecurity issues, which we have seen in the developed world and don't want to sort of see replicated with new connectivity? Second question is, given that you're building new technology to build this connectivity, what options are there to jump ahead and use that to create security that maybe is absent from the legacy internet that we're currently working with?
Robert or Marion, your
So-
thoughts on that?
So Google is typically not acting as an ISP in any of the ventures that I talked about. So what we do is we provide the ISP all the tools that we have in terms of security to help them, but we ourselves are not taking responsibility for that since it's typically left up to the ISP.
We've got security,
Yeah.
like a lot of us.
Yeah.
I mean, from the control of our satellites to the control of the terminals to locking terminals to ground stations to even some proactive things about security, about looking at apps and which apps on smartphones will be, how a smartphone is acting, whether it could be violated or not, and some of those things that Qualcomm is doing that we're building in and embedding in our system. So there's actually, but security is a broad topic. Like it goes from A to Z and probably beyond. I can't address it all, but it's definitely a hot topic for us.
One of the advantages of building technologies today is we know what, again, when I talked earlier about identifying and filling gaps, sort of early internet technology was not designed with a lot of security in mind. We know that, so just as we're designing new networks and new technologies today, it's one of the things that you design in from the beginning. So it's a different approach. It's not bolted on later. It's sort of from the beginning.
Unlike them, we're really not limited to any individual country. So because we're not terrestrial or low Earth, so or really low Earth. So we deal with countries individually with their own security issues and how to make sure their users are secure within their own country networks. That's another level of security and challenges. But we're all over it.
We have time for one more question right there.
I have an offer, not so much an ask. My name is Joe Krause. I'm with the One Campaign. We're an advocacy and campaigning organization with 7+ million members around the world. And we come at this from the development perspective, where our aim is to end extreme poverty in Africa. So we've worked with some of the groups in this room on connectivity already. But since we are an advocacy organization, we're working with governments both in the global north and the global south, trying to change regulations, change policies to actually help improve connectivity. For instance, right now we're pushing the G20 to include in their compacts for Africa as part of the Marshall Plan that the German government, which is hosting this year's summit, has put out, trying to get them to include a commitment to helping connect all classrooms in Africa in the next 3 to 5 years. What can we as an advocacy organization, how can we work with your organizations to help convince policymakers to make the regulatory changes that are necessary? We're not experts on this issue, so what advice would you have to us in terms of when we go to governments? What should we be asking for? What should we be pushing for in terms of policy? And then also we play, I think, a pretty unique role in the NGO space of bringing together lots of unusual suspects. 2 years ago, we helped launch the Global Partnership for Sustainable Development Data, bringing together private sector, civil society, lots of governments. I think when we launched, we had over 60, and then now it's several hundred. So offering our services to partner with anyone who's interested in trying to advance our combined goals. Thanks.
Yeah, so short answer is we actually are, I think you may know, already partnering very closely with One and working with you on all of those issues, particularly on trying to close the gender gap in terms of access and use of the internet. So yeah, it's for those of you who don't know One's activities in this area, it's actually, you know, it's great and it's easy to work with you. So thank you.
Thank you so much, everyone. Well,
I just came yesterday from India. Thanks to Manu, I was invited here. So I've installed about 70,000 streetlights in India, in 15 states of India. And I see the Google in all the train stations, and it's amazing to see how kids come over there and they study there. And there are more kids in the station than passengers. So it's a great feeling to see that. And I've also installed about 100,000 home lighting systems in 15 states in India, where there's no electricity, which you very rightly said, that you have to have the electricity to have the connectivity. And I am so happy to be here to see all you guys. And I would love to help in getting your dream together. So we can discuss later how I can help. Thank you.
thank you, everyone, for coming. Thank our guests, please, for
Thanks to Cecilia, our moderator. Yeah, thank you all for those of you who were able to hang in, because it was really worth hearing fully from these folks. Just before you all leave, I think Manu wanted to make one quick request.
You know, I think Michael, myself, a number of you in the room have been talking about thinking strategically about how can we support these connectivity efforts, both international and domestic, including Global Connect. And there's been a lot of support from individual companies and individual people. I just want to make sure that we let you know that we're actively thinking about this together, strategically, about how we can continue a partnership, either through New America or through other organizations, to ensure that we continue to sustain and build a